Hi everyone, I want to zip through a couple of extra examples here so that you can try the next page of this packet on your own if you want to. So let's look at, for example, f of t equals 7 minus 3t times 1 plus 2t cubed. And let's say we're trying to find f prime of t. And I want to do this two ways. I want to do it the new way and the old way. The new way is we have a product rule, so we can use that. The old way would be to multiply it out ahead of time. Okay, so let's do the product rule first, since that's our new thing. The product rule says if you look at this function, and you can see that the big operation, the last thing you would do is multiply. So here we do exponent, and then we do some multiplication, and then we do addition. So everything inside the parentheses, and then the last thing is that multiplication. So we need to do the second exactly as it appears. And then we'd multiply that by the derivative of this entire first thing. So the derivative of 7 minus 3t is going to be a 0 minus 3, so just negative 3. And then it's a plus in the middle, and we'd have the first exactly as it appears, 7 minus 3t, and then we'd multiply that by the derivative of the second. So the derivative of the 1 is 0, the derivative of 2t cubed, we dropped the 3 down in front, we get a 6t squared. And then we need to multiply that out to do some simplification. Having something in factored form is great, but this like partially factored, but the big operation is sum, that's really not a useful form to have things in. So either fully factored or fully multiplied out is good. So I'm just going to go ahead and distribute it and get it fully multiplied. I see a negative 3 minus a 6t cubed, and then I see a 42 t squared minus an 18t cubed, which means I can do a little bit better. I see a negative 3 plus a 42t squared minus a 24t cubed. Okay, so there's my answer. Okay, so that's the new way. Let's compare it to the old way. So the old way, we would start with this exact same thing. F of t equals, so this is alternative, you don't need to do both, but it's nice to see if they really do give you the same result or not. Okay, so the old way would be to do the work up front of multiplying this thing out. So we'd get a 7 plus a 14t cubed minus a 3t minus a 6t to the fourth. And then we would take the derivative. Derivative of 7 is 0, so now I've written it as sum or difference, so we'll just work our way down the list. So the derivative of the 7 is 0. 14t cubed, we drop the 3 down and we get 42 t squareds. The derivative of negative 3t is just negative 3, and then minus 24t to the third, and it looks like it does match up perfectly. And it looks to me like actually our old way was a little bit easier in this case. So I do want to say that I'm not arguing that the product rule is always the easiest way to do these things. It absolutely is a little messy. So in a situation like this, it might be easier to multiply it out first and then take the derivative. But make sure you're practicing your quotient rule a lot. And I do hope that you'll realize that you can't always rewrite something so that there is no product. So sometimes it's not optional. In this case, there's a way to rewrite it so it's not a product, but that's not always true. Okay, let me show you just a couple more. So I'm going to say I have y equals e to the z times z to the negative root 11 plus 58z. And I want to take the derivative. So again, it's good to ask yourself, can I make this easier by simplifying first? And in this case, if I distribute through, I actually don't think I've made it any easier. Right now I have this product right here. That's the big operation. And it's pretty easy to take the derivative of e to the z or of the stuff in parentheses. If I distribute, it's going to make two product rules for me. So I'll have an e to the z times the z to the negative root 11 and a 58 e to the z times z. So I'm going to leave it. You'd still be able to get the right answer that way, but it doesn't seem to help. So I'm going to go dy dz, derivative of function y with respect to variable z. And I want the second exactly as it appeared, multiplied by the derivative of the first. So this is my second, and this is my first. The derivative of the first is a nice, easy one. E to the z is its own derivative. And then we get a plus the first, and then we want to multiply that by the derivative of the second. Okay, so the second is the sum. We'll look first at the z to the negative root 11. The z, the variable, is the base, so it's a power rule. We'll drop the negative root 11 down in front. And then the new power, this one's a little bit messy, is negative root 11 minus 1. And then we have to add the derivative of 58z, which is just 58. Okay, so simplify. Once again, this happens a lot with product rules. We have this sort of big operation as a sum, but then there's these weird factored terms involved. So I would either factor it completely or multiply it out completely. It doesn't really matter which, but I think in this one, it's really easy to factor an e to the z out of both terms. So we get e to the z out in front, and what we're left with is this z to the negative root 11 plus 58z. Just times 1 now, and then the negative root 11 z to the negative root 11 minus 1 plus 58. So notice those inside parentheses don't actually mean anything anymore. There's nothing hooked to them, so they're grouping in a situation where no grouping is necessary. It doesn't matter what order you do this addition subtraction in. So I'm going to go ahead and drop those, and then the only other thing, so this is all dy dz, is we're supposed to write things without negative exponents. So I'm going to work on that a little bit as well. So this is going to become 1 over z to the root 11. And then my plus 58z looks fine. And then I have minus root 11. And this one I actually think is really interesting. Here, we do want to move this down into the denominator, but you want to think really carefully about how that works. If you move something down into the denominator, it's like multiplying its entire exponent by -1, or you can think about it this way, you can factor out. So if we look at it as -1 times root 11 plus 1, when we move it to the bottom, that gets rid of the -1, which changes both. So this is actually going to be root 11 plus 1. A lot of people want to leave the -1, and it's not quite right. And then we have a plus 58, and that's all done. So that's kind of a messy one. Okay, let me do one more. Nothing too terribly messy here, but just to make sure we've seen a good mix of functions. Let's say w equals 3 to the x times cosine of x. Okay, so if we want the derivative of function w with respect to variable x, 3 to the x is our first, cosine x is our second. So we'll do a second times the derivative of the first. The derivative of 3 to the x is itself multiplied by the natural log of the base 3. And then we'll get the first, 3 to the x, times the derivative of the second. Derivative of cosine is a minus sign, opposite of sine. Okay, and then again, you don't really need to do much on simplify here. I would deal with this negative sign, just make this a minus. And the other thing you can do is factor out a 3 to the x. It's not required, but later we're going to do some solving where that factoring will be good. So I think it's a decent thing to practice now. So we'll have the cosine of x multiplied by the natural log of 3 minus the sine of x. All right, thanks for watching.